meaningful use of symbols. We have to make sure that the kids know the symbols in mathematics because they're really important for them. It's one reason that students aren't successful in algebra is that they don't have a strong understanding of the symbols. Like I said, the equal sign is one of the most important symbols in mathematics using numbers and operations. Kids need to know that the equal sign, we have to remind the kids that the equal sign is same as, so they don't have to get confused. Also, it is important for students to see and understand the symbolized in relationships in a number system. And also, one way to help students understand the equal sign is to explore equations as true and false. So, for example, we could tell them 2 times 4 equals 8. Is that true? Or, well, true or false? We could start by saying, is it true or false? 2 times 4 equals 8, or 4 times 2 equals 6. So we'll tell them which one is true, so they could tell us 4 times 2 equals 8. So it's really important for them to know the symbols to like plus and minus and multiplication, because right now, like when we're doing our activity, they were saying 4 plus 4 equals, but we're working on multiplication. They need to know the difference. Okay, the meaning of variables. We all know that variables are different in math. Like we said, they could be unique as unknown values. For example, in algebra, we could put 2 plus x equals 8. So we would have to find x. So the kids need to understand the variables in math as well. Like right here, like I put an example. The minus, the plus, the multiply, the division, and the equal sign. And then also there was I like this example. Maybe we could use it like 3rd grade and up. And it says, write the missing number, the shape, or the same number. So right here, the square plus 6 equals 10. So they would have to find the square, the number for the square. So 6 plus 4 equals 10. So right here they will write their answer. And right here they will write 4 as well, so they could know that the equal sign is the same as. So 4 equals 4. So right here we also have a different example, but with triangles. You guys could use different shapes, so we could teach the students.
Okay, and we have the study of patterns and functions. We have repeated patterns, which is real concepts and number patterns. Like for example, when we use 2, 4, 6, 8, 10. Like 3, 6, 9, 12. And we have growing patterns. We have the recursive explicit formulas, graphs of functions, graphs of content, and graphs and rate of change. Like for example, we have a pattern right here where we have it's like a game where they can go like 1, 2, 3, 4, 5, and they have like a pattern from 1. We also have the linear functions, the rate of change and slope for older kids, and the proportional and non-proportional situations in the parallel and perpendicular lines. We also have the making structure in the number system explicit. When we make a number system explicit and understood the structures, not only are the students tools for computation, but also enrich their understanding of the number system and provide a base of even a higher levels of abstraction. And in this case, we have the properties of multiplication, addition, and we have like the commutative, like Madeline was working with their students. Like for example, we know that 4 times 2 equals is the same as 2 times 4. And we also have the other properties like the distributive, associative, additive property, and the multiplication property.
So to wrap it up, we need to, like, mathematical models, like, are not the blocks or the things, the manipulatives that we use. It's actually the equation or the function that the students use to solve a certain algebraic problem. So they're used to predict others' phenomena, and they are not to be confused with the models that use manipulatives or visuals for building patterns.
The equations or mathematical models allow us to find values that cannot be observed in the real phenomenon. So like for example, like the X value, like find the value of X, or the profit, and if you sell a certain amount of candy and you pay a certain amount of price for that candy and you sell it another price, you want to get like your profit overall, and all of those equations that you create are the models that you use to explain to the kids how to use the certain equation to fit in and plug in different values to get an answer. We have to make considerations with the students, like we have to emphasize appropriate vocabulary. Like for example, right now, like the students were saying 3 plus 4, and it was like 3 times 4. Like we have to differentiate like what is the sign of the different operations that we do. Like for example, the independent and dependent variables in an algebraic problem. Like for us, it's kind of easy, like the independent is the one that doesn't change, and the dependent is the one that depends on the other one. But for students, like you have to like teach it like explicitly, like the discrete and continuous, like the domain and the range, and things like that. So for multiple representations, we can use the context. Like when you have a problem, the word problem can help you make your formula to use. Or the tables, we can create a table that has the values plugged in using the formula. And you can make connections between all of them so that the students can use the one that like works better for them. Like graphing, symbols, or verbal description of the problem and the function and why are they using that formula. So we have to connect representations. So like I said, for a given function, different representations illustrate the same relationship, and students should be able to explain connections across representations in a conceptual manner. So the context and the graph and the tables all have to make sense for the student to understand why are they making all of those different like concepts. The movement about representations is about making sense of the function and not about following a root procedure. So it's not like a procedure that they have to do, like it's like the function that they have to make, like to make the connections with the function in the model. So algebraic thinking across the curriculum, we use it in measurement and algebra. We use it in data and algebra, like when we scatter plot like different answers of students and things like that for experiments. And like I said, scatter plots and that.